Welcome back to Balvigyan Bharti. In today's chapter, we'll start from the problem number 28 in probability. It says, from a pack of cards, 3 cards are drawn at random. Find the probability that each card is from different suit. So, to start with, have to explain the different types of cards that are there in the playing card. You know that the count is 52. 52 number cards are there in a playing card. There 4 segments are there. 4 segments are there. These are clubs, dice, heart, and spade. These are the 4 major classification of cards. In each card there are 13 different uh, 13 different type of card are there, but this type are same in all these 4, but individually they are different from each other. That is the meaning of that. So that means 4 into 13, where each 13 are similar in way, apart from their color and the shape of the symbol, they are all are same. I mean to say, if I take king as a mark of king, that all those having the same similar mark, but symbolically clubs is different from dice and that of from heart and spade. So I mean to say, when we try to pick a different suit for 3 cases, then my possible outcome should be such that all 3 card, if I say these are the 3 card I'm picking, 3 card must be different in a way that must be 3 different from 3 different segments. The first requirement is they must from different segment, and in each segment they also must be of different kind. That means if I say I have picked 3 different segments, club, dice and heart, for an example I'm saying, there if club is picked the king, dice should not pick king again, or the heart should not pick king again. They must pick maybe out of the other 12 alternatives for the second choice, and other 11 alternatives from the other alternatives from the 11th choice if heart is being picked third. So I mean to say, their chance of picking going down. So there must be different in different segments and different types together. So that means if I say broadly, my probability of getting a different suit card, so that is a combination of getting different segment cards and different type card. If I correctly can distinguish by S and T, S means the broader segments and the type means the type where this 13 different type is available. So my favorable outcome is a combination of different segments and different types. So different segments we were talking about, so there are 4 possibilities. So my pick of card must be 3. So 4 out of 3, that means 4C3 is the chance of picking different segments into, out of this 3 card picked must be again of different types from all 13. So that means if I pick first card from clubs, So from clubs there are 13 alternatives. So 13C1 would be the exact number of card that is possible for the first card, and for second card it is 13C2 for the other segment, and that of 13C1 from the other segment, and the third also similarly having the possibilities to pick from 13 different cards in a way of 13C1. So that means first picking 3 cards from different segments. After picking 3 cards, their possibilities from getting different suits are this is picking 3 card and picking different 3 card from different segments will be clubbed with AND. That means picking 3 different segments and picking different suits of first card and picking different suit of second card and picking different suit of third card. So all this together will give you the result of picking different suits, and this will be in the numerator, and the denominator will give you how much the probability you pick any 3 card from. If I say there is a total number of card of 52, when you are picking, you are not segregating these segments, you are picking randomly any 3 cards. When your combination meets, that will be the ultimate favorable condition. But when you are picking from out of the all total, so your total probability of getting 3 cards have to be considered from 52 cards in a manner of 15C3. So this will be your answer then for this required favorable condition. Okay. So now you further can solve it by your own. I am not going to solve it for you, so you can try it at home. Okay. The second one means 29 and second for this class. Find the probability that a leap year has 52 Sundays. Has 52 Sundays. So now if you are knowing the difference between the normal year and a leap year is a day's difference. Normally we are having 365 days. In a leap year we are having 366 days. Now if I divide the days in week, so in each week we can get one Sunday. Okay, so now if I divide with 7 of any of these two, if I divide 7, I will get 52 into 7 will give you 364 days. 7 to the 14, 35 plus 1, 7. So in a year there is a day remaining, that could be any day, and in leap year that is 2 days remaining. Now as we are talking about leap year, we'll think on 366 days. So out of 52 week, if I divide 7, so in a year you don't know where the year starts. So as it is divided by 7 and 52, so 52 definitely Sundays are coming. Find the probability that the leap year has 52 Sundays. So now any year 52, if I get the complete number of week with dividing by 7, I am already getting 52 Sundays. So this 2 Sundays, 2 days must be such that it won't carry any Sunday. Then only my count will be totally 52. So now what are the possibilities of getting 2 days? How? That could be 2 consecutive days definitely, because this is ending with 2. So that could start with Monday, Tuesday. Okay, this first possibility. Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and Sunday, Monday. These are the combination that we can get for these 2 days, because 2 days are consecutive. So starting with Monday, ending with Monday. So in this combination, only two such combination where Sundays are coming. So if I don't want to get further any Sundays, because this is already actually 52 Sundays, so in this combination what we would do, we would take where Sundays are not coming. 1 2 3 4 5 cases out of 7 cases. So my probability of getting no Sundays in a leap year, only 52 Sundays, if I eliminate these two cases, so the probability of getting Sunday and not getting Sunday together will give you 1. So probability of not getting Sunday is my requirement, that is 1 minus probability of getting Sunday. So probability of getting Sunday is 2 out of 7. So what is my result? 5 out of 7. So this will be my probability of getting 52 Sundays in a leap year. Understand? Okay. So moving to the next problem, that is 30 problem. This says 15 people sit around a circular table where, what are odds against two particular people sitting together? So that means in this case, to start with, I have to explain few things, because I have not yet taught you that the permutation and combination. This all this kind of concept is being taught in permutation and combination. But even though, if I see it now, when we arrange something in a linear way, let's say I am arranging 4 thing, 1 2 3 4 number in a linear way. So I can start any number anywhere, but wherever I start, let's see, I am starting with the first position. So this first position is having some significance. That means it calls as a first position depending on there is no seat on its left and all other seats are remaining on the right side. So that means it has a specific position. I cannot tell this position as a first position, because this is having 1 left and 2 on the right. So this cannot be the same as this position. Whereas if I do it in a circular way and all these 4 seats are marked on a 90-degree apart, so this position, whether it is the first position or this position or this position or this position, what is the first position, that deliberately cannot be said. But once it is occupied, any place being occupied, then with this reference I can say whether it is on the left or right or front. So once a place is occupied, that means the first position is occupied, then with this reference I can refer the places. So in a circular manner, the first position is not significant or null and void. You cannot say the first position is this. So this is the difference between a linear arrangement and a circular arrangement. This concept is required when we will consider the circular permutation. So that is a different chapter, but as of now this concept is only required for this case. Now and the result for a circular permutation always comes the number of variable, that means number of your count, or in this case if I say the 15 people, so that means 15 is the count for the event. So that means this number, if I mark it as n is equal to 15, so for a circular arrangement, my result of orientation, the probable result of orientation is always n minus 1 factorial. So this is the number of ways I can arrange people in a circular manner. How it is come? If I take a small example of 4 people, so for first position, as I said, Once I will not occupy any position, I cannot say it is first position. So for first occupancy, the way possible, because if I sit here, then on also there is a left, right and front. If I sit there also, there is always a left, right and front. If I sit there, so all these positions are similar. So the first position, then the way of sitting will always be 1. Once if it is occupied and I mark it as the first person occupancy, then for the second person there is always a choice, right? There is a choice of this and this. So from the second person there is a chance of 3-way. Once this is occupied, let's say the second person occupied this position, for the remaining 2 there is a chance of 2, and once this is occupied or this is occupied, the remaining is 1. So this way, when that 4 person is occupying in a circular manner, their way of sitting is coming 3 into 2 into 1, that means 3 factorials. That means this can be written as 4 minus 1 factorial. This way, when it is 15 or any number n, the way when it is being occupied in a circular manner, their number of possible results is n minus 1 factorial. Okay, from this way, if I put n is equal to 1, this will be 15 minus 1, that factorial, that means 14 factorial. So this is the way when 14 individual occupy a circular table or circular arrangement. Now this is saying what are the odds against two particular people sitting together. That means when I choose 2 person who wants to sit together or who are deliberately or intentionally being put together one after one in a circular way, that means if somebody has occupied this, the companion will occupy this or this. Okay, so that means if I consider this 2 person as 1 person, because they are moving always together, so my chances of arrangement comes down from the count of n is equal to 15. There I can consider this will be 14, because 1 and 1 together will count 1, because they are always sitting together. So that means in this case, when it is such that they want to sit together, my way of arrangement must come down by 1 more. So this will be 14 minus 1. Okay, because 2 is count as 1. So this is 13 factorial. So this is the way. But these 2 person can interchange their positions. So their sitting arrangement again internally can be 2 different way. Either he sit there or sits there, so they can interchange. So this again multiplied by 2, because their places are interchanges. So total count where 2 person can sit together, this is the favorable outcome. Out of the total outcome is always 14 factorial. So this will be the probability for this event or requirement. Understand? Sorry, this requirement. So this is factorial 3 into 2 and factorial for the total probable outcome. Okay. So I will end up here because I have just switched off fan. I am very difficult to continue longer videos. So kindly excuse me. I am ending here and I will continue from the next problem 31, the next video. Good night.